Let us start coordinate geometry, some important formulas pertaining to the lines. This is the distance between the 2 points. If A and B are the 2 points and the coordinate of A is x1, y1 and coordinate of x2 and y2, so here the AB will be means the distance between the 2 point AB, that will be the root of x2 minus x1 whole square plus y2 minus y1 whole square. Here you see the distance between A and is equal to x2 minus x1 and distance between B and is equal to y2 minus y1. So by applying the Pythagoras theorem, we can find out the value of AB. The same thing has been done here. Now the second part, coordinate of the points of division internally. You see that there are two points P and Q. In between them there is a point R whose coordinate is to be found out. Let that the coordinate of the R is x and y, and this R point divides the PQ in the ratio of m1 is to m2. So the ratio between PR and RQ is given. So in similar triangle, you see the triangle PKR and triangle RSQ. You see, this is at S and K, the point angle is 90 degree, and this is corresponding angle because RS and PK is parallel. Therefore, at the angle at the point R, that is R and P both are corresponding angles. So once two angles are equal, therefore these two triangles are similar. And once it has been established that the triangles are similar, then the sides are proportional. So I have written here PR by RQ. PR by RQ means that the ratio is given here. So PK by RS, corresponding sides should be proportional. So PK by RS is equal to RK by QS. So m1 by m2 is equal to x minus x1 upon x2 minus x1. I have mentioned here. You see x minus x1, here x2 minus x. So to solve for x means the coordinate abscissa for R will be equal to m1 into x2 plus m2 into x1 upon m1 plus m2. And for ordinate, that is y, for the point R will be m1 into y2 plus m2 into y1 upon m1 plus m2. So in this way we can find out the coordinate of the internal point which divides the given line segment in the ratio of m1 and m2. Now externally, in similar triangle here, you see the P and Q are the 2 points. There is a point outside of this line segment, that is R, x, and its coordinate is xy. The coordinate of P and Q is known, that is x1 y1 and x2 y2. We have to find out the coordinate of R, which divides externally the line segment PQ in the ratio of m1 to m2. You see then similar triangle PKR, and the second angle is QSR. So the corresponding sides should be proportional. So PR by QR is equal to PK by QS, RK by RS. Here PR and QR, that is M1 by M2. Here PK pk will be equal to x minus x1 and upon qs, which is qs, that is x minus x2. Here I have mentioned it here. Similarly for y minus y1 upon y minus y2. So just by cross multiply, if you want to find out the first and second part, you just cross multiply and find out the value of x. That will be equal to m1 x2 minus m2 x1 whole divided by m1 minus m2. For y means ordinate y, that is m1 into y2 minus m2 into y1 upon m1 minus m2. So a very important formula is this, that the denominator there is a minus and in the numerator also there is a minus. Now, if the vertices of the triangle is given, we have to find the centroid of the triangle. You see, ABC is a triangle where AD is the median, means D is the midpoint of B and C. So the coordinate, you see, the first of all, coordinate of the point A, vertex A is x1, y1, B is x2, y2, C is x3, y3. So the midpoint that is D is the midpoint of BC. So therefore its coordinate will be x2 plus x3 upon 2, y2 plus y3 upon 2. Now we have to find the centroid, that is G. So G means that is the centroid where all the medians intersect each other or concurrent at the point G. That point is known as the centroid. Now centroid divides the median in 2:1 ratio. Means 2 towards the vertex part and 1 towards the side, whose midpoint has been joined with the vertex. So here you see x1 means 1 should multiply 1 to x1, it will be x1. While you multiply 2 to this abscissa, that is x2 plus x3 by 2. So 2 and 2 will be cancelled. So we are left with x2 plus x3. You see, x2 plus x3. In the denominator, we have to add it 2 plus 1, that is 3. Previously, we have learned how to find the coordinate of the internal point which divides the given ratio, that is 2:1, it is here. Similarly, for k means the k is the ordinate of the point G, the centroid, that will be equal to y1 means 1 will be multiplied to y1. So 1 into y1, that will be y1. Now we multiply 2 to the ordinate, that is y2 plus y3 by 2. This 2 and this 2 will be cancelled. So we will get y1 plus y2 plus y3 upon 2 plus 1. 2 plus 1, that is 3. So I have here written, I have written here, that is 3. Now area of the triangle. You see, area of the triangle of ABC. ABC is here. Its vertices are given, that is x1, y1, x2, y2, x3, y3. So I have dropped the perpendicular BM, AL and CN to the x-axis. So there is trapezium, you see, BMLA. It is one trapezium, BMLA. Second trapezium is ALNC. This is the second. So, and there is one trapezium also, that is BMNC. BMNC. So this is the, so on adding the first trapezium, second trapezium, and subtracting this trapezium, you will get the area of triangle. So here I have mentioned it here. Area of triangle ABC will be equal to the area of trapezium ABML plus area of trapezium ALNC minus area of trapezium BMNC. So on subtracting, you will get the area of ABC. So just to apply the formula, you see it will be equal to 1 upon 2 x1 into y2 plus x2 into y3 plus x3 into y1 minus in bracket x2 into y1 plus x3 minus y2 plus x1 into y3. How we can establish this formula? You can see just I have written here for your guidance, that is x1 y1, x2 y2, x3 y3, x1 y1. I have started from the A, later on B, C, again A. You see x1 y1, x2 y2, x3 y3, x1 y1. The dark line will be multiplied, so we will get the positive sign. You see here x1 y2, you see x1 y2, x2 y3, x2 y3, x3 y1, x3 y1, and the dotted line means after putting a minus inside the bracket you write down that is x2 y1, x2 y1, x3 y2, x3 y2, x1 y3, x1 y3. So or either you just remember this formula or this. Area of triangle ABC will be equal to 1 by 2 of x1 in bracket y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2 bracket closed, and that will be equal to 1 by 2 determinant x1 y1 1, x2 y2 1, x3 y3 1 in the form of determinant I have written here, and it can be also written like this. The area of the triangle will be equal to 1 by 2 summation of x1 y2 x2 minus x2 y1. Either you just understand this one formula or you have to remember this long method, and if I have understood this formula, you can easily elaborate it. Means x1 y2 x2 y1, just interchanging. Now note, I have mentioned here the area of the triangle is always positive. In case getting negative sign, then ignore the negative sign and take it in positive way, that is mode of that values. Second part is that A x1 y1, B x2 y2 and C x3 y3 are collinear points lie on a straight line, then the area of the triangle is 0. Third point, if a quadrilateral A, that is x1 y1, B x2 y2, C x3 y3 and D x4 y4 is given, then you have to write down these coordinates like this. First of all, you write down x1 y1, x2 y2, x3 y3, x4 y4, x1 y1. From where you have started, you have to end it there also, at the initial point. Now, you see, the dark line will be the positive one. You see, 1 by 2 x1 into y2, x1 into y2 plus x2 into y3, x2 into y3 plus x4 into y1, x4 into y1. In this way, you find out the value of first bracket minus in the second bracket I have mentioned here that is x2 y1 plus x3 y2 x4 y3 x1 y4 I have mentioned it here. So you have to remember all these points while you are solving it. Now the straight line, the equation of axis means what will be the equation of x-axis, that is equal to y is equal to 0. If you put y is equal to 0, you will get the value that is the equation of x-axis. Equation of y-axis, that is x is equal to 0. Put x is equal to 0, you will get the value of y-axis. Now the B part, that is the equation of lines parallel to coordinate axis. Coordinate axis means you have to draw a line parallel to x-axis or you draw a line parallel to y-axis. And there is possibilities that if you are drawing the line parallel to x-axis, it will be either upper part of the x or lower part of the x. Similarly, in the y-axis, the line parallel to y-axis will be on the left hand side or right hand side. There are two possibilities. So parallel to x-axis will be equal to y will be equal to plus minus a. Parallel to y-axis, it will be equal to x is equal to plus minus b. Now the C part, that is the equation of a line in the form of gradient. You see the line AB has been drawn and it makes theta angle with the positive direction of x-axis, and it intercept on the y-axis is C. Let us take a point P, x, y on this line and drop a perpendicular on x-axis, that is PM is the perpendicular drawn, and the point C where it intersects the y-axis. From here you draw a line parallel to x-axis which intersect PM at the point N. So Pn will be equal to y minus c. You see, y is from this point to this point and this is c. So just subtract c. So I have written here y minus c. Now proceed here, y minus c by x. Y minus c by x, that will give you the tangent theta, that is equal to m. So from here cross multiply it, you will get y minus c is equal to mx. What is m? That is tangent theta. Mx plus c. The gradient tangent theta, that is m. If the line passing through the origin, then c is equal to 0. At that time c will be equal to 0 and the equation is y is equal to mx. Now proceed to the D part, that is equation of a line in the intercept part. You see, there is a line AB which intersect y-axis and x-axis at the point A and B. So OA is equal to small a and OB is equal to small b. These are the intercept on x-axis and y-axis. So here you see there is one formula how to find out, that is area of the triangle OAB will be equal to, you know the vertices, we know the vertices of the triangle. So you see 0 into 0 minus b plus a into b minus 0 plus 0 into a minus 0 minus 0. That will further solve it, you will get 1 by 2, 0 plus AB plus 0, that will be equal to AB by 2. Area of the triangle OAB is equal to the area of trapezium OLPB. You see, area of the trapezium OLPB plus area of the triangle PLA. So the area of the triangle OAB is 1 by 2 base into height. So you just take it base and this is height. So A into B divided by 2. The area of trapezium will be equal to sum of the parallel side divided multiplied by height. Half of the sum of the parallel sides, that is y plus b divided by 2 into multiplied by x, means perpendicular distance, that is x here. So you see, I have written here 1 by 2 a into b is equal to 1 by 2 y plus b into x plus 1 by 2 y into a minus x, that will be equal to ab. Here just open the bracket, you will get yx plus bx and ya minus yx. You see, yx minus yx plus yx, these two will be cancelled. So we are left with AB is equal to bx plus bya. This implies that x by a plus y by b is equal to 1. This is the required equation. The second method, by similarity of the triangles OAB, the bigger one, and PLA, the smaller one triangle. So B upon A will be equal to y upon a minus x. Here it will be y and this portion will be LA, that is a minus x. So I have written here y upon a minus x and cross multiply it, you will get AB in minus bx is equal to ay. That will be equal to x by a plus y by b is equal to 1. This will be the required equation in the intercept form of a straight line. Now equation of a line in the perpendicular form. You see, AB is the line which intersect y-axis at B and x-axis at A. So there is a perpendicular drawn from the origin to the line AB at the point L. L is the foot of the perpendicular. So O and K, you see, O and K. Here you see O and K is equal to 90 minus alpha. O and K, you see, O and K, that will be, you see, it is 90, this is 90 degree, sir, this is alpha, this is 90 degree, this is O and K, so O and K plus alpha is equal to 90 degree because these two angles are complementary angle. So I have written here the O and K is equal to 90 minus alpha, means O and K is 90 minus alpha, therefore M and P will be equal to alpha. You see, from here we have taken a point, arbitrary point, that is xy, its coordinate is xy. I have dropped a perpendicular to x-axis. From here N, I have dropped a perpendicular to OL, which foot is K. So P and M, you see the P and M, that is 90 degree, alpha degree, alpha. So ON is equal to ON, you see ON is equal to X. This much means abscissa, because the coordinate of the point P is given, that is XY. So ON is equal to X. Here I have mentioned it. ON is equal to X. PN is equal to Y. You see, the PN is equal to Y. In right angle triangle ONK, OK is equal to ON cos alpha. OK is equal to ON cos alpha, that is X cos alpha. I repeat again. OK, this is, and this is 9 alpha. This is 90 degree right angle triangle at K. So the OK is equal to ON, means hypotenuse into cos alpha will be equal to OK. And OK is equal to how much? Sorry, ON is equal to how much? That is X. So X cos alpha will be equal to OK. Now in right angle triangle PNM, that is alpha degree. So PN is equal to Y sin alpha. PN is equal to Y sin alpha. Here the perpendicular is at M. So you see, in right angle triangle PNM. So Pn is equal to Y sin alpha. So OL is equal to OL, complete perpendicular, that is OL is equal to OK plus KL. OK plus KL. In place of KL, I have used PM. PM is equal to KL. So OL is equal to OK plus KL, OK plus PM. So the P means the perpendicular drawn from the origin to the line. That is P, X cos alpha plus Y sin alpha. Then this will be the required equation. Now the second method which I have written here, you see, BOL, that is 90 minus alpha. Therefore OBL means this angle. OBL means this angle, that will be equal to alpha. So OA is equal to OA is equal to, complete this, you see, OA is equal to P sec alpha, secant alpha, and OB is equal to P cosecant alpha. Now apply intercept formula, that is x upon a upon plus y upon b is equal to 1. So here I have written, you see the intercept is P cos alpha, P sec alpha. So x upon P sec alpha plus y upon P cosec alpha, that is equal to 1. So this reciprocal of sec alpha, that is equal to cos alpha. So x cos alpha plus y sin alpha is equal to P. This will be the required equation for a line in the form of a perpendicular. Now the general equation of the first degree, that is ax plus by plus c, its degree is 1. So any equation having the first degree that represent the straight line. So here a, b, c belongs to real number. Prove that the equation of the first degree represents a straight line. Proof. Suppose the above said equation passes through the point x1, y1, x2, y2, x3, y3. then the coordinate of these points satisfy the given equation. You see the given equation I have written here, that is ax1 plus b1y plus c equal to 0. This is the first equation. For the second one I have written here ax2 plus by2 plus c is equal to 0. That is the second. ax3 plus by3 plus c is equal to 0. That is third equation. By eliminating a, b, c of these equation by determinant method, we can find out here x1 y1 plus x1 y1 1, x2 y2 1, x3 y3 1 should be the value of this determinant should equal to be 0, which represent that the area of such a triangle is 0, or in other words these points are collinear. So ax plus by plus c is equal to 0 represent a straight line. Ax plus by plus c can be transformed in gradient form. Here I have written here y is equal to minus a by bx plus in bracket minus c by b. So y will be equal to mx plus c. Now compare it. You will get the value of m is equal to minus a by b, and intercept, that will be minus c by b. The slope of the gradient of the line is, from here you can just understand, that is minus coefficient of x upon coefficient of y. Now proceed to the second part. In the intercept form, ax plus by plus c is equal to 0. This implies that ax plus by is equal to minus c. So a by minus c into x plus b by minus c into y is equal to 1. So x upon minus c by a plus y upon minus c by b, that is equal to 1. Now further you can solve it, that is in the form of x by a plus y upon b is equal to 1. It is in the form of intercept form. So intercept on x-axis is minus c by a. Here I have mentioned it. Minus c by a. The intercept on y-axis will be equal to minus c by b. Now the next, to represent in perpendicular form. So ax plus by plus c, this is the general equation of the first degree of for a straight line, that is ax plus by is equal to minus c. So what I have done, that I have taken the square root of the sum of the squares of the coefficient of a, coefficient of x and y. That is root a square plus b square into x. Here numerator is a. So a upon plus minus root a square plus b square bracket band into x plus b upon plus minus root a square plus b square bracket closed and multiplied by y. You see the minus c will be equal to plus minus root of a square plus b square and bracket closed. So here x cos alpha plus y sin alpha is equal to p. Here cos alpha is equal to a upon root a square plus b square. Here I have written here cos alpha is equal to a upon root a square plus b square. Sin alpha is equal to b upon root a square plus b square, and taking the square root after that. Here the perpendicular distance, that is p minus c by plus minus root of a square plus b square. Here the length of the P means perpendicular. It will be always positive. So we have to adjust. This plus minus is given. So we will choose that sign which will give the ultimately the plus sign. Because the value of P should be always positive. That plus minus, from this we take only that sign which makes the value of the P positive. Now proceed. Two other important equations of lines. A line passing through a point whose gradient is known, that is y is equal to mx plus c, where m is its gradient. If it passes through x1, y1, this implies that y1 is equal to mx1 plus c. Subtracting second from first, we have y minus y1 minus y minus y1 is equal to m into in bracket x minus x1. Now if this line is passing through the point x1 y1 and x2 y2, the equation of line passing through x1 y1 is y minus y1 is equal to m into bracket में x minus x1, where m is the gradient. If this line is passing through x2 y2, that is y2 minus y1 is equal to in bracket x2 minus x1. In order to eliminate m, divide first by the second, we have y minus y1 upon y2 minus y1 is equal to x minus x1 upon x2 minus x1. Now it can be further solved. So y minus y1 is equal to y2 minus y1 upon x2 minus x1 in bracket x minus x1 is the required equation of the line passing through x1 y1, x2 y2 and its gradient is equal to y2 minus y1 upon x2 minus x1.